Imagine staring into the night sky, a canvas of twinkling stars, and wondering, where did it all come from? For centuries, we've pieced together the story of the universe, from ancient myths to modern science. But what if everything we thought we knew was just the beginning? What if a single image, captured by a telescope floating a million miles from Earth, could unravel our understanding of reality itself? Welcome to the edge of human knowledge, where the James Webb Space Telescope is rewriting the rules of the cosmos. Let's start with a bombshell. The Big Bang Theory, the cornerstone of cosmology, is facing its toughest challenge yet. For decades, we've believed the universe began 13.8 billion years ago in an unimaginably hot, dense explosion, expanding ever since into the vast expanse we see today. It's a story that's held up through countless experiments, from detecting the faint glow of the Big Bang's aftershock to measuring the speeds of distant galaxies. But now, the James Webb Space Telescope, or JWST, has thrown a curveball. Its latest images, crisp, breathtaking snapshots of the universe's deepest reaches, are sparking debates that could change everything. These aren't just pretty pictures. They're cosmic clues that might force us to rethink the universe's birth, its growth, and maybe even its future. So what's got scientists so excited and a little worried? It all comes down to a number called the Hubble constant. Think of it as the universe's speedometer, telling us how fast everything is flying apart. The faster the expansion, the younger the universe might be, the slower, the older. Simple, right? Not quite. Measuring this number is like trying to catch a shadow in a storm. Astronomers use two main methods, and here's where things get weird. They don't agree. One method looks at nearby objects, like stars and exploding supernovae, to gauge distances and speeds. These are our cosmic yardsticks, known as standard candles because their brightness is predictable. The other method peers back to the universe's infancy, studying the cosmic microwave background, or CMB, a faint whisper of light from when the universe was just 380,000 years old. This CMB is like a baby photo of the cosmos, full of tiny temperature ripples that reveal how fast the universe was expanding back then. Here's the problem. The local measurements say the universe is expanding faster than the CMB measurements suggest. This discrepancy, called the Hubble tension, isn't just a small rounding error. It's a cosmic conundrum that's been puzzling scientists for years. If the local measurements are right, the universe might be younger than we thought. If the CMB is right, something's off with our nearby observations. Either way, we're missing something big, maybe a new force, a hidden particle, or a flaw in our understanding of the universe's machinery. Enter the James Webb Space Telescope. Launched in 2021, this marvel of engineering is humanity's most powerful eye on the cosmos. Orbiting far from Earth's glare, its massive golden mirror captures light that's been traveling for billions of years. JWST can see galaxies so distant they formed just a few 100 million years after the Big Bang. Scientists hoped its data would settle the Hubble tension once and for all, giving us a clearer picture of the universe's expansion. But instead of answers, JWST has given us more questions. Its first wave of data confirms the same troubling mismatch. The universe seems to be expanding faster than our models predict. This isn't just a glitch. It's a signal that something fundamental might be wrong with our story of the cosmos. Let's take a closer look at the CMB, because it's one of the most powerful tools we have. Back in the 1960s, two scientists accidentally discovered this faint microwave hum coming from every direction in space. It was a monumental find, proof that the universe had a fiery beginning. The CMB is the light left over from when the universe cooled enough for atoms to form, letting photons stream freely. By studying its tiny fluctuations, hotter and cooler patches in the sky, scientists can calculate the universe's age and its early expansion rate. It's like reading the universe's birth certificate. But when we compare those calculations to measurements of nearby galaxies, the numbers don't match. It's as if the universe grew up faster than its baby pictures suggest. Why does this matter? Because the Hubble tension isn't just about numbers. It's about the very laws of physics. If we can't explain why these measurements disagree, we might need to rewrite our understanding of gravity, energy, or even time itself. Some scientists are starting to wonder if we've missed a new kind of particle that zipped around in the early universe, tweaking its expansion. Others think dark energy, the mysterious force speeding up the universe's growth, might behave differently than we thought. Dark energy is already a wild card. It makes up about 70% of the universe, yet we barely understand it. Could JWST's findings be hinting at a new chapter in its story? Speaking of mysteries, let's talk about dark matter. This invisible stuff doesn't emit or absorb light, but its gravity holds galaxies together. Without it, the universe would be a much emptier place. Scientists estimate dark matter makes up roughly 27% of the cosmos, yet we've never directly detected it. We see its influence through gravitational lensing, where massive objects bend light from distant galaxies like a cosmic lens. JWST's sharp infrared eyes are perfect for studying this lensing, revealing how dark matter is sprinkled across the universe. But here's another twist. The way matter is distributed today doesn't quite match what we see in the CMB's early universe snapshot. This mismatch, known as the S8 tension, suggests the early universe was smoother, more uniform, than the clumpy galaxy clusters we observe now. The S8 tension is like finding a puzzle piece that doesn't fit. When the universe was young, matter was spread out evenly, with tiny ripples that grew into galaxies over billions of years. The CMB shows those ripples in exquisite detail, but when we look at today's universe, full of dense galaxy clusters and vast empty voids, the distribution seems off. Gravitational lensing helps us map dark matter's clumps, but the data doesn't line up perfectly with the CMB's predictions. Are we misinterpreting the CMB? Is dark matter behaving in ways we don't understand? Or is there something else at play, some unknown force or particle we haven't accounted for? JWST is helping us dig deeper into these questions. Its images show galaxies forming earlier than we expected, some so massive they challenge our models of how the universe evolved. These early galaxies are like finding fully grown trees in a young forest. They shouldn't be there yet. Scientists are now wondering if our timeline of the universe's growth is wrong, or if some unknown process sped things up. One team, led by a cosmologist named Risai, thought the Hubble Space Telescope's measurements might be off, causing these discrepancies. But when they checked with JWST's sharper data, the same deviations appeared. Risai put it bluntly in an interview. Somewhere between these observations, there's a fundamental flaw in our understanding of the universe. This is where things get thrilling. Every time we've uncovered something new about the cosmos, it's forced us to rethink what we thought we knew. Take the CMB's discovery in 1965. It was a smoking gun for the Big Bang, silencing critics who thought the universe was eternal and unchanging. In the 1990s, we learned the universe's expansion was speeding up, introducing dark energy into the equation. Each discovery builds on the last, like chapters in a book we're still writing. JWST's findings are the latest chapter, and they're some of the most dramatic yet. What makes this moment so exciting is how it shows science in action. Cosmology isn't a dusty textbook. It's a living, breathing quest for truth. The Hubble and S8 tensions are frustrating, sure, but they're also opportunities. They're pushing scientists to develop better tools, design new experiments, and dream up ideas that might sound like science fiction today, but could be fact tomorrow. Maybe we'll discover a new particle that changes how we see the early universe. Maybe dark energy isn't a constant force, but something that evolves over time. Or maybe we'll find that gravity itself works differently on cosmic scales. The universe is full of surprises, and JWST is our guide into the unknown. Its images aren't just data. They're windows into a story that began 13.8 billion years ago. Picture a galaxy so far away its light left when the universe was a toddler, now reaching us after a journey longer than Earth's existence. Each photon tells a tale of creation, expansion, and mystery. And with every new image, we're learning that the universe is stranger, more complex than we ever imagined. So what does this all mean for us? It's easy to feel small under the weight of these cosmic questions. We're just specks on a tiny planet, orbiting an average star in a galaxy among trillions. But here's the flip side. Our curiosity, our drive to understand, makes us part of this story. Every scientist peering through JWST's data, every person gazing at the stars, is connected to the universe's grand narrative. The Hubble tension, the S8 tension, The mysteries of dark matter and dark energy. They're not just problems for experts. They're invitations for all of us to wonder, to question, to explore. As we speak, scientists around the world are racing to unravel these puzzles. They're analyzing JWST's data, building new telescopes, and running simulations to test wild ideas. Some are even revisiting the Big Bang itself, asking if our core assumptions need a shake-up. Could the universe have started differently? Could there be forces or dimensions we can't yet detect? These questions are daunting, but they're also what drive us forward. Science thrives on the unknown, on the moments when we realize there's more to learn. Let's zoom out for a moment. Imagine you're floating in space, watching galaxies spiral, stars ignite, and the universe stretch into infinity. Now imagine that somewhere in that vastness, there's an answer to why it all exists. JWST is bringing us closer to that answer, one image at a time. But it's also reminding us how much we still don't know. The universe isn't a puzzle we'll solve overnight. It's a journey, one that's been unfolding for billions of years and will continue long after we're gone. So, the next time you look up at the stars, think about this. We're living in a golden age of discovery. The James Webb Space Telescope is showing us a universe that's wilder, more mysterious than we ever dreamed. The Big Bang Theory might be wobbling, but that's okay. Science isn't about being right. It's about getting closer to the truth. Whether it's the Hubble tension, the S8 tension, or the enigma of dark energy, each challenge is a step toward understanding our place in the cosmos. What do you think? Are we on the brink of a new cosmic revolution? Could JWST's discoveries change how we see the universe forever?